Okay, this is going to be a quiz review for algebra on Thursday, the 2nd of October. And we are looking at a study guide 2-5. This is page number 24. We're solving equations with the variable on each side. For those of you in class that have heard me say it before, I'm going to use the over-under method. Again, if the whole grabbing it like a claw and moving things around works for you, keep doing it. I'll be demonstrating the over-under method, and I will also only be working problems that are the closest to what you might see on the quiz. There are several problems on here using fractions and decimals that I really won't use this week, anyway. Okay, so on number 1, I generally like to try to get my variables over on the left-hand side. So the 5b needs to be moved. It's a positive 5b. So the opposite of that is a negative 5b. So I'm subtracting that. What I do to one side, I have to do to the other, no matter what. Okay, so what that's going to give us then, on the right-hand side, the b's go away. On the left-hand side, we would get a negative 1b minus 5b makes us a negative 6b. And we just bring down the 6 that was already there, and this is going to equal 30. Our next step is going to be moving this constant, 6, right here, and we're going to do that by subtracting it on the left and on the right. And so what that's going to leave us with is a negative 6b equal 30 minus 6, which is 24. Clear some space up here. So this is now saying negative 6b, negative 6 times b, in other words, is equal to 24. In order to undo that 6 times b, I need to divide by negative 6 on both sides. My b is equal negative 4. Alright, you can always pause and rewind these things to watch a step again. Moving on to number 2. Number 2 is one of these new guys you guys have probably never seen much of, except this few weeks of school, in that it's going to come out to have no solution. And here's what that means. First off, we need to combine what's already on the left-hand side, so we would get 5 minus 2y, or 3y, equal 3y plus 2. I would like my 3y's over on the left, so I would subtract negative 3y. Negative 3y. And what that gives me, they go away over here on the right, and you get something that is really nonsensical in that these completely go away and give you a 0, and you would end up with 0 equal to 2. Well, of course that's not true. So when it's not true in algebra, we say no solution. That's the symbol for no solution. It looks like a 0 with a line drawn really big all the way through it. You could also write no solution abbreviated, no sol. But this is possible. If the numbers we get are not equal, then it's no solution. The alternative to that is going to we'll look at number 18. Again, a lot of people are really used to always seeing x equals 10 or x equals negative 3 or whatever. It's possible to have no solution, and it's also possible to have a solution that says all real numbers. Number 18 is an example of a problem that comes out to be all real numbers. Here's what that looks like. Again, my preference, I like to have my variable over on the left, so I'm going to start with adding 4r right there. Draw the lines if you need them. And so what that means is over on the right they go away. On the left, we get a plus 4r. And they go away too. That produces a 0 plus 5 equal 5. Now the next step is to get this 5 over to the right hand side. And so what you get then is another kind of curious result saying 0 equal 0. Well, that's true. It does. 0 does equal 0. So if you get a 0 equals 0, then, and so therefore it's true, the answer is all real numbers. And that's the symbol. It looks kind of like a jazzed up R. What all real numbers means is no matter what variable I pick for R, let's say I picked the number 3. If I picked the number 3, then I would have negative 4 times 3, or negative 12, plus 5, equal 5, minus, again, 4 times 3 is 12. And if you add negative 12 and 5, you're going to get a negative 8. And if you say 5 minus 12 in your calculator, you're also going to get a negative 8. So no matter what number I used for R in this particular problem, it would give me two numbers equaling one another. Again, therefore, this is all real numbers. Let's go back up and work number 3. It's again very much like what you will see on the test quiz tomorrow. And where are you? There it is. Okay. Once again, I'll say it. Generally, I want my x's over on the left. Okay, it's possible to move them over to the right, and you would still get the same answer. But generally, I'm going to try to move them to the left. That means that I want to subtract 2x here. Subtract 2x on the left-hand side too. That would give us 3x plus 2 equal negative 10. Then I'm going to get rid of the 2 on the left. Do it on both sides. This will produce 3x equal a negative 10 minus 2 is negative 12. Clear some room. And we have 3x equal negative 12. Divide both sides by 3, and you get x equal negative 4. Alright, maybe one more example. We're running up against 10 minutes, and that's 10 to 12 minutes is about max. Let's see here. We will do... I said I would work something that looked like... I'm sorry, I'm sitting here looking and not seeing an example. Never mind. We will just work problems looking like what I've just shown you, and we'll do number 14. It's 11, 12, 13, there's 14. Alrighty. Subtract a 1k over here. Subtract 1k over here. That's going to give me 8 plus 3k equal negative 10. K's went away over here on the right. And we're going to subtract 8. Subtract 8. On the left, the 8's go away. 3k comes down. Equal negative 8 minus 8 is a negative 18. And now we have a multiplication problem that we can undo. Dividing by 3, dividing by 3. Our k is finally equal to negative 6. Alright, again, probably around 10 questions on that test, and we'll see you tomorrow.